Hello friends, today we are going to solve the problems of GATE 2025. So in February you have already appeared and the question papers are now available. So I would like to deal with all the problems of GATE 2025. This is the first problem, uh, which is the given data for this problem. It is related to three-phase diagram. You see this, the void ratio is given to you. So in this problem, the void ratio, degree of saturation, water content, specific gravity, unit weight of water, all these parameters are given, and the volume of the soil is also given to you. So volume of the soil is 5 meter cube. So the information here is void ratio E, then degree of saturation SR, then moisture content or water content W, the specific gravity G, and unit weight of water. All are known to us, and therefore you can correlate all these quantities, and you can get for the given soil mass what is the moist unit weight, because degree of saturation SR is 0.67, that is it is 67%. So if the degree of saturation is 67%, naturally it's in moist condition. So you can find out the unit weight, moist unit weight. So moist unit weight gamma moist can be found out from the given information. So what is gamma moist? It will be G is also given, G plus E into degree of saturation SR into gamma W, unit weight of water, divided by 1 plus E. So now if you see the data here, the value of G is already given as 2.67. So let's write it, 2.67 plus the void ratio is 0.6, and degree of saturation is also 0.67, and unit weight of water is given to you as 9.81 kilonewton per cubic meter, divided by 1 plus E will be 1.6. So you can get the value of gamma moist. Now what you need to calculate the weight of water required to make the soil fully saturated. To make the soil fully saturated, the unit weight will be gamma saturated. So for fully saturated condition, you can calculate the gamma sat from all this information or all the given data. So here from the given data you can write it G plus E, because degree of saturation becomes 1. For fully saturated condition, the degree of saturation is going to be 1. So G plus E into 1 into gamma W divided by 1 plus E. So naturally, if you substitute the values, G is 2.67 plus 0.6, E value into 9.81 divided by 1.6. So this will give you in kilonewton per cubic meter the value of gamma saturated. So you get gamma moist, you get gamma saturated. Let us take our calculator and calculate it. So if we calculate, let us see what value we get it. 2.67 plus 0.6 into 0.67 multiplied by 9.81 divided by 1.6 equal to 18.83. So we are going to get the value of gamma moist as, so if you calculate, you will be getting this value of gamma m, which is coming out to be 18.835 kilonewton per cubic meter. And if you calculate this, let us calculate this 2.67. This is 20.049. 20.049, so you can say 0.5 kilonewton per cubic meter. Now, in order to calculate the weight of water required to make the soil fully saturated, this gamma saturated is defined as weight of saturated soil per unit volume. The volume is already given in this problem as 5 meter cubes. So this can be written as W saturated. So this implies that the weight of saturated soil mass will be gamma sat, which you have calculated as 20.05 multiplied by the volume, that is 5. So if you calculate it, multiplied by 5, there is 100.245. So 100.245 kilonewton. That is the weight of saturated soil mass. Now you know gamma moist, therefore weight of moist soil mass you can find out. Gamma m will be weight of moist soil per unit volume. So this implies that weight of moist soil will be 18.835 multiplied by V, that is 5. So 5 multiplied by 18.835. This is 94 point. So we get the weight of moist soil is 94.175 kilonewton. So if you take the difference, weight of saturated soil minus weight of, so if you draw a three-phase diagram, let's say this is a three-phase diagram, this is the solid and these are the voids. In moist condition, it is going to be water as well as air. So this is the complete weight, total weight of moist soil. Now, the moment you are going to have it fully saturated, then air is replaced by water. So the weight of water required to make the soil fully saturated can be found out from weight of saturated soil minus weight of moist soil. So weight of saturated soil minus weight of uh, moist soil will give you the weight of water required. So the weight of water required will be difference of 100.245 minus 94.175. So the weight comes out to be 6.07 kilonewton. So there is the answer. The answer, weight of water required to make the soil fully saturated, is going to be this one. So the answer is crystal clear. This becomes your answer. So weight of water required is 6.07 kilonewton. It's quite simple problem. You can see in two steps from all the given data which you have at your hand, calculate saturated unit weight, calculate moist unit weight, and from these saturated unit weight, find out saturated weight of the soil mass for the given volume of 5 cubic meter, calculate the weight of moist soil from the unit weight for moist soil for the given volume of 5 cubic meter, and then the difference of the two will give you the weight of water required to make the soil fully saturated. So in two steps, the solution can be met. Very simple problem that has been asked. So conceptually, if you know, and my video on three-phase diagram, I have dealt with all these concepts. So my previous videos, if you look to on three-phase diagram, you will be able to recollect all these points, and you can see in two steps the answer can be obtained. The moist unit weight, one step, and saturated unit weight, second step. And this gives you the weight of moist soil, and this gives you the weight of saturated soil. Take the difference and find out the weight of water that is required for making the volume of soil, which is 5 cubic meter, fully saturated. So this problem is so simple that we have seen. Now we will take the next problem that has been asked this year in GATE examination. So friends, the next problem of GATE 2025 will be explained to you. Now, the head difference is the second problem between upstream and downstream. and downstream uh, end of flow net. So head difference is 9 meter. So the number of equipotential drop between upstream and downstream side is 10. And if the length of the flow field length of the flow field near the tube is given as 1 meter, and gamma saturated below the dam that is the saturated unit weight below the dam is 21 kilonewton per cubic meter. So gamma saturated is given to you over here, 21. Then calculate the factor of safety. Factor of safety for quick condition. This is the problem that has been asked in GATE 2025. Very simple problem. Again, you can see the solution. What is the factor of safety that's being asked? So you have a dam. Earthen dam is there. This is the upstream side. This is the downstream side. And the water is flowing. The head difference between upstream and downstream end of the flow net. So for the flow net, delta H, the difference in the head is given to you as 9 meter, and the number of equipotential drop between upstream and downstream side is also given over here is 10, and the length of the flow field near the tube is also given as 1 meter, and gamma saturated is given to you. So such a simple problem, you can find out, calculate the factor of safety. So you will have to calculate the factor of safety, which is given by hydraulic gradient, critical hydraulic gradient, that is I critical divided by exit hydraulic gradient. So that is I exit. This is the factor of safety. So this is going to be important for all of you. Now, what is this value of I critical? So I critical, I can calculate it. You know it, it is gamma prime divided by gamma W. So numerator I critical, the critical hydraulic gradient is given by this. Now I know already the saturated unit weight and I know the unit weight of water. The difference of the two will give me the submerged unit weight divided by gamma W. So you can calculate this very easily. The value will be gamma saturated is going to be 21. Gamma W is 9 point unit weight of water divided by 9.81. So you can calculate the critical hydraulic gradient very easily. Then in the denominator, I can also calculate the exit gradient, and the exit gradient is given by the loss of head delta H over a particular length. Length is given to you, it is 1 meter. The length L is given to you as 1 meter. So denominator is 1 meter. And the delta H you can always calculate as the total head between the head difference between is 9 meter over the total equipotential drop of 10. So it is going to be 9 by 10 divided by 1. So you can calculate this also. So calculate this, take the calculator, and then you can calculate the factor of safety. So in this problem, this is also one step problem. You see, this year paper seems to be quite simple if you know it. So 21 minus 9.81 divided by 9.81, 1.14. So you are getting I critical as 1.14. This is the value of I critical, and I exit is 0.9. So naturally, I can find out now the factor of safety. Therefore, the factor of safety equal to 1.14 divided by 0.9. So divided by, this is giving you 1.267. This is the answer. So calculate the factor of safety for quick condition. So for this quick condition, the factor of safety is critical hydraulic gradient divided by what is the actual hydraulic gradient, exit hydraulic gradient. And always the actual hydraulic gradient should be less, then only the factor of safety will be greater than 1. So you have seen that it is lower, the exit hydraulic gradient is only 0.9, whereas the critical hydraulic gradient is 1.14. Naturally, you get a factor of safety, this one. This is a quite simple problem of GATE 2025. Let's go to the next problem now. So the next problem I will be dealing. So the next problem is on pile groups. The group uh, pile group 4 by 4 equal to 16 piles in a square pattern, having length equal to 20 meter and diameter of the pile as 0.5 meter. The group efficiency factor is given in this problem as 100%. That is eta g equal to 1. Eta g, we call it group efficiency factor. If you see my video on pile foundation, group efficiency factor, I have elaborated in detail regarding group efficiency factor in my videos on pile foundation. So all of you, I would advise to go through those videos, and I have already solved such problems in this, and you can see the problems how it is being asked. The average unconfined, the average unconfined compressive strength Qu is given as 100 kilopascal. So that's also given to you. Alpha value has been given in the examination as 0.8, although this is on the higher side, but it is given in the question paper like that. Neglecting bedding of pile, calculate pile spacing. Yes. So this is the problem. So we will look to the solution. How many piles are there? Total 16 piles in a square pattern. So 4 piles, 4 by 4, this is a square pattern. The center to center distance is going to be spacing, yes. So BG, the width of the group is going to be 3 times spacing plus d by 2 on this side, d by 2 on this side, it becomes d. So 3s plus d is the width of the group. This is also BG because it is a square pattern, 4 by 4. So 16 piles have been arranged like this. Length, diameter is given to you. Group efficiency factor eta g is 1. That's given to you. What is eta g? Eta g is defined as the ultimate load carrying capacity of the pile group as a group. What is the ultimate load carrying capacity? Divided by number of piles. Here the number of piles are going to be 16. So n is the capital N is the number of piles into the ultimate load carrying capacity of single pile. Now, if you want to find out the value of QUG, therefore QUG, the ultimate load carrying capacity of this pile group 4x4 will be n number of piles into QU of single pile multiplied by eta g. So based on, this is based on individual shear failure. I have already explained this based on ISF. So number of piles, now you can calculate QUG based on this. So number of piles 16. QU of 16 pile, because you will have to neglect the bearing. So if you neglect the bearing, it will be only a frictional pile. And if it is a frictional pile, for a single pile, it will be pi d L, perimeter into length, that is the surface area of the pile. So pi dl multiplied by alpha times Cu, and bearing is not to be taken. So pi dl into alpha times Cu, that is the value of single pile, and eta g is given to you as 100%, that is 1. Now, if you simplify this, 16 into pi into d into L into alpha. Now, Cu will come from unconfined compressive strength Q equal to 100 kilopascal. Therefore, Cu will be Qu by 2, that is 50 kilopascal. So here Cu you take it as 50 and calculate this in kilonewton. So you know the value of QUG. This is based on ISF. Now, based on block shear failure, when this pile group is going to fail as one single unit, it is called group shear failure or block shear failure. So based on block shear failure or group shear failure, the formula for QUG, the ultimate load carrying capacity of the pile group, will depend on what is the value of BG. So total perimeter becomes 4 times BG because it is in a square pattern. So perimeter is going to be 4 times BG multiplied by length of the pile. So the pile group, what is the length of the pile? You multiply it. So perimeter into length, that becomes the complete area of the pile groups, and the skin friction is going to act over there. So multiplied by alpha times Cu, that is the value of skin friction. So alpha times Cu gives you the skin friction. So QUG already you have calculated based on ISF. You can substitute over here, and BG is already in terms of spacing. It is 3 times spacing plus D. D is 0.5 meter. So this can be further elaborated as 4 multiplied by BG will be 3 times spacing plus D is going to be 0.5 meter multiplied by length, that is length is given to you as 20 meter into alpha is already 0.8, Cu is given to you as 50. And QUG, you can just calculate it. So let me take my calculator and uh, you can just see. So here, based on ISF or individual shear failure, QUG, we can calculate it. So it is, you see, 16 into 0.5. 16 into 0.5 into 20 into 40 into shift pi. This is 20,106. So QUG therefore comes out to be 20,106.19. This is the value of QUG. So for block shear failure or group shear failure, here I can substitute QUG as 20,106.19 equal to 4 times BG. This is BG, width of the group, which is 3 times center to center spacing between the two consecutive piles plus 0.5 into length into alpha into Cu. So the only unknown is here the center to center spacing. So S equal to can be found out. So let us simplify this. So divided by का 80 गुना 40. So minus, so I am getting 3s plus 0.5 equal to 6.283. So if I deduct minus 0.5, I get it 5.783, that is the value of 3s divided by, so center to center spacing finally comes out to be 1.927. 1.927 meter. So this is being asked, this is the answer. So the calculate this center to center spacing, this is the answer. So very simple way. The step 1 is this formula. Step 2 based on block shear failure, this is the second step. And you can finally calculate this. In 2 steps, this pile groups problem can be solved very easily. And this I have already explained in detail. The concept of block shear failure, concept of individual shear failure in my pile group design of pile groups. If you go to my previous videos, initial videos on pile foundations, complete theory has been explained. how in pile groups the skin friction will get developed uh, on the periphery when it is failing under block shear failure as one unit, one monolithic unit. If it is individual shear failure, the pile will fail one by one. So these things have been explained. And very intelligently, the question has been set in gate examination on pile foundation. I've seen even in engineering services examination, such problems are being asked on pile foundation. So hopefully all of you must be going through the different videos. A lot of videos we have prepared, and conceptually I have tried to explain there. And here also I am trying to give you the complete idea of how to calculate the center to center spacing between the two consecutive piles. So with the help of diagram, I hope these things are clear to you. You have seen 2025 gate problems being solved over here, and we will be continuing in our next video the rest of the problems. So thanks a lot for having visited my site and trying to learn conceptually the method of solving the problems. You have seen the gate problems are quite simple this year. Thank you.